another episode of Power Insights, Power Magazine's video interview series. As with other industries, the power industry is grappling with multiple shocks generated with the pandemic, among them financial distress and a cultural shock stemming from an abrupt shift in workforce practices. Digitalization in some respects has been a saving grace, and much of it has been driven by technology. Joining me today to talk about the magnified value digitalization offers under the circumstances is GE Digital's new Chief Technology Officer, Colin Parris.
Before we get started, I'd like to take a moment to thank our sponsor, the 2021 Connected Plant Conference. For more information on this event, please visit www.connectedplantconference.com.
Thank you for coming, Colin.
Oh, my pleasure, Sonal. I'm delighted to be here. Honored that you'd ask.
Thank you.
So I have done a lot of digital transformation as it applies to several industries, starting off in banking, communications, commerce, healthcare, and then moving into the industrial industries. And you see there are certain similarities along the way that make sense, and there are certain major differences. So when I look inside overall the power industry, the two things I always think about in terms of trends. One is a trend of productivity, the other is a trend of dynamics. So in productivity, usually with every industry, what you want to do is do more with the same amount of people you have or do more with less. And that was there in power from day one. How do I take out cost? Now, as a result of COVID, it's how do I do productivity, but how do I do it remotely, which is very interesting. The second trend is all about dynamics. So every time you watch a market, the market begins to evolve, and you see things coming in that cause a lot of variability. So in the power market, you have renewables coming in, you have new demands from customers showing up, you have government policies showing up, you have cyber showing up. A lot of demands. How do you deal with that? Now with COVID, you see those demands not only in terms of long range, but you see absolute short-term dynamics. For instance, I talked with NIPA, and NIPA said right away, you know what, we have to go remote. You talk to Sonal Gas, one of the other good customers we have, they wanted to get to remote right away. Instead of having 5 people in a command center, 3 of them are running remotely from home. You see the same thing with what's going on with the Indian utility companies. So this dynamics has changed. So think about productivity and think about market dynamics as big trends, that historically software and AI have solved. But now with COVID, this is accelerating in dramatic ways. So those are the things I tend to look at. If I look at the same analogies from prior industries, the next thing you see much further on is data. So because you have to deal with productivity and because you have to deal with market dynamics, you collect massive sources of data to handle productivity, right? I need to get the data to actually predict when failures will occur. This way I make my workers much more efficient. I deal with data when I'm trying to deal with massive market dynamics because I need to optimize. When I collect that data, all of a sudden I have a massive data platform. And that data platform permits a significant amount of new business transformation to take place. So I could watch these trends around productivity, market dynamics, supporting that, and then I watch it go to an emerging digital platform, and from that, mighty new industries are formed. So that's the way I think about what I see here. And the pattern is quite similar, although it's different because of the complexity of each industry. We have safety to deal with in this industry. We have massive financial, investments. We have cultural shock as we begin to change these things. You have great dynamics with renewables coming in. So each one is slightly different, but those are the trends I see.
Is there a specific business value or is there going to be some kind of change as you see that applies to digital technologies because of the changing working conditions?
No, I think there's huge business value. It's interesting. Every time you look at these things, when you go talk to the customers, they say, well, remote work, that's something we can't do. But then what COVID did was it forced you to do it. But more than forcing you to do it, it also forced you to be forgiving, to accept the fact it's not perfect initially, and to deal with the fact that with this lack of perfection, we still have to find our way through. So people had the ability and the excuse to fail, but fail and learn rapidly. And we see it happening. So let me give you an example. So here's a good one. This is Pasoko. Pasoko is the Indian utility, huge Indian utility. So they're dealing with two issues. One is the fact that, in India, 7 or 8 million people are on lockdown. The prime minister then says something like, for unity, what I'd like you to do is everyone turn off their lights for 9 minutes. You have 1 billion people turning off their lights for 9 minutes. Did we ever foresee that on the grid? Did we ever build anything that would allow that to happen on the grid? Nah, not at all. So what happens? And he gives you 60 hours notice. So quickly, you move to two things. You quickly get to the software you have. We have the AEMS software. This is what controls the grid. But we also have to quickly lock into the engineers to understand what they're doing right now. So we use remote work, which is some of the capabilities we have to quickly tie into their systems, and we use AEMS. And we find a way to do this. So we go from 130 gigawatts is what normally, is the entire Indian grid. It's running at 50 because of COVID. Now we anticipate it's going to be a drop of at least 12 gigawatts. But when they actually turn the lights off for the 9 minutes, it drops 31 gigawatts. And because we have the software capability with the smarts in it, we stabilized the grid and we recovered. And because we were remotely working, we were able to tie in and collaborate with the key engineers at key sites, and we're monitoring things remotely just to see if something does happen, how do we react in those 9 minutes, or how do we react when we're coming up? That we would have never tried to experiment with at all, but because we did it. Now they're saying, this worked. What does this actually mean? So could we do stability even better? Could we do it remotely? Now that you have this one proof point, the whole insight of the customer changes. That to me is profound. So now you see remote working action. Same thing in Algeria. Algeria, we have Sonelgas, right? This is the Algerian utility. There again, they're worried about what's going to happen with COVID. They have a command center. Their command center runs APM. They've got 10,000 sensors monitoring all this new equipment they have. Now those people, they're saying, let's get these people at home. We need them not working from home. We can now, again, using remote technology, remotely show all of those screens and have them work together. And they use tools like Skype and Microsoft Teams. But that combination, they never thought they could have done it. Now that they can do it, they're saying, why don't we do this? So there is a profound change that's happening here, not only in terms of does the technology work, but it was given permission to work because you had to just do it because of what you had. Now the culture is changing. So this is it. This will begin to pick up. Now, let's be honest. If that does pick up, we've got to think about cyber much, much more appropriately now as we see that happening. Also, we've got to think about the fact that if you don't have enough people on that site, you need more smarts in the software at that site. So this is where your digital twin capabilities at the sites come in. Because that twin has got to be on site looking at things that you wouldn't normally see. It's got to be adapting as quick as you can and then giving you back this information, and then you manage it remotely. So now it's got to be tied into the control system. You can't deploy a person at a plant because that person may not be there to do something. So all of these things in terms of twins with AI, with remote capability, are now coming to be.
Are there any specific insights that they have given us in terms of how plants are managed or oversight at the plants specifically?
I think they are. The question, though, is how do you interpret those insights, right?
Right.
So, for instance, in power generation, what you have is now you have a situation in which, because the world was shut down in some sense, you couldn't go in and do normal parts disposition. So maybe you had a normal maintenance, right? You couldn't get people in there to do it because you couldn't get people in, in your plant locally, and then you couldn't fly in experts because flights were shut down. So many companies came to us and said, can we elongate, right? Can we add one more tour, or can we add 3 more months before we do a maintenance? Now, in order for me to add 3 more months, I've got to look and say, I got to make sure if I say keep that thing running for 3 more months, I am not going to cause an outage in the system at all. So how do you do that? You got to look at a digital twin. You got to have the twin give you a view of what's the current state, and then you got to run that twin and say, let me just simulate a little bit more to see where it will go. Yes, you need a lot of people. next to that twin because you don't have the perfect set of data. But the twin gives you enough of it that you could begin to say, can I actually extend that outage, the maintenance actually, for another 3 months? And because of that, I can go allow this plant to run without putting people in harm's way. And in some cases, you just can't get the parts in. So you see some things that are directly in use when you're doing these type of things. You also see, for instance, the network digital twin. When you talk about what we did at in India, you actually had to look at that network digital twin and say, well, if you did actually shut this thing down, for 9 minutes, what could potentially happen? And then you had to have a bunch of different backup plans in place. So you had to be thinking through, well, okay, based upon that, say we run a simulation, we think this and this and this could have, okay, let's go and look at that parts, understand, can it recover fast enough? Can it actually ride through that instability? So again, the twins giving you insights all the way through. So these things become more and more valuable. And again, become great proof points, because that's the biggest thing now, it's a proof point.
The concept of a network twin is extremely interesting. Has this been tested beyond India?
No, well, it's not so much as tested, because in many cases, so if you think about twins right now, twins are essentially models.
Right.
That's what a twin is. What makes a digital twin very useful now is that's a living, learning model. We have many models of things right now. The trick with it is that we never seem to update the models in real time, or update the models using data that's coming from the fleet, learnings that you get from elsewhere, whether it be a simulator or other people in the fleet. What our twins are now doing is we're taking the twins that we have, because you've got to start with where you have, and we're now beginning to give them that ability to be living, getting data in all the time and learning. These are the things that we're adding. So we have, some initial twins running in the networks we have right now that we're using. And then we're supplementing that with other insights we have to get the full scale of digital twins for it to be living and learning. So some of them, people will tell you they already have a twin because I have a twin of the network. But is it a digital twin that's living and learning? Not yet. But some of it is living in that it's taking real-time data. So we're using some of those, right? And they're in different parts of the world. The degree of capability for it to live and adapt with real-time data varies. Some of it, it's very few of them know to learn from what's happening in the fleet, or what's happening from humans, or what's happening in simulation. So that's where we are right now. So there are twins around helping us, and we've been exploiting that for the last few years in GE.
What are the benefits of digitalization in this space at this time?
So now that's a great point. That I think is the key question we need to be answering. So if I think about what a twin and digitization does, there are 3 things I want to look at, right? Well, actually 4. The first thing is, can I get early warnings? Can I get early warning of a potential problem? Now in this world in which we're going to have, a potential recession, I'm going to have less people, less resources. How do I, even with less people and less resources, get that early warning? Because the quality that you have to deliver and the safety still remains the same. Nothing changes. So can I use that? And yes, I can use twins and digital capabilities to give me earlier warnings. I can use that prediction system and that diagnostic system that I have that's looking for anomaly detection to tell me when something's going wrong early enough so that I can do some type of counter effort to stop it. The next thing is, so that's early warning. The next thing is to do prediction. Can I predict when things are going to fail? Because now what I have to do is, because I have less people, less resources, I may need to set up maintenance or any type of repair operation 2 years in advance, as far in advance as I can. And I've got to plan what parts will I need. I don't want to waste $1 on a part that I won't need. So now if I can do that and predict that, I can have a lot lower inventory, as a customer. And I can exactly put the people I need at the right place and understand, get the right capabilities there at a lot lower cost. So that's prediction. Then it's optimization. Okay, I need to actually now deal with a recession. Okay, the gas, fuel prices are low, which is a good thing, but I still need to optimize everything else I do to make sure I can deliver that electricity at the lowest possible price. So now I look at that and I say, okay, now I've got to find ways to go do this. And so that's the twin helping me in optimization. There's another thing that we use the twin for. Maybe the example here is CDP. CVP is the Competitive Partner Ventures, right? What they do is they have a twin, we call it OPM. This twin actually allows you to fire the turbines and run it hotter when the price of electricity is the highest, and to run it cooler when the cost of electricity is the lowest. And the reason you want to do this is because what you don't want to do is cause an outage, and you want to keep to your same maintenance cycle. So imagine I have an asset. Right now, my asset, whenever the price of electricity is high, I don't sell any more electricity. I just say I'm happy. Whenever it's low, I say, well, I mean, this is what I have to do. Now I can actually vary the control systems because of the digital twin, and I can run it hotter, when the price is high, right? And so, yes, when I run something hotter, I burn up the life. I damage the parts. But to compensate for that, then when the cost of electricity is low, I run it cooler. I use more fuel. Okay, but the price of fuel isn't that much. So if I use these OPM solutions with Dispatch Optimizer, I can now optimize me making the most amount of money. And I don't need people to do this. The digital twin is doing this for me. Mm-hmm. Right? So that's the third thing about optimization. And then the last one is simulation. I need to simulate and run a bunch of simulations to do what ifs. COVID was so unique. All right, what if there are other spikes in COVID? What happens? Can I plan for that? What if there are other pandemics? Can I plan for that? What happens when new factories come on? What you'll also find is that factories are going to fail all over the world. So all of a sudden, I expected I was going to get a ton of money coming in from this part of the Middle East. Well, there's no demand for it. How do I sit down and do a simulation to understand which machines do I shut off? Which investments don't I make? So all of these things, from early warning to continuous prediction to dynamic optimization to simulation, these are the things you have to do. And if you don't have the digital infrastructure with the twins and the AI to do it, you're at a significant disadvantage. So this is actually perfectly set up for what we will face over the next 4 or 5 years. Yeah. Colin's thoughts. Because who knows what happens at that point,
You mentioned cybersecurity, cyber issues. There's been a lot of activity on that front. We've seen a lot of regulators bring their hands. Basically, we're looking very carefully at the risks. So what do you think we should be facing, or we will be facing, as things continue as they have been?
We are already facing risk, and we will face more. I mean, that is just what is inevitable. But let me talk about two different types of risks. One is the cyber risk. Right. The other one is the business risk, right? Because every time you look at risk, there must be a risk-reward, playoff. So let me talk about the rewards first, and then we put the risk in context. So here's the rewards. The rewards is you literally have to run with less people. Okay, there are ways to use that. Now, if you are using this digital technology, you want to minimize business risk. So for instance, we have the technique called humble AI. I'm using a digital twin that's built on data. If I use a lot of data from a specific period in the year, say I got a lot of data for whatever reason between May and July, then the twin I build between that time frame, in that warm season for me, is going to be very good because I have a lot of data. Whenever I use a lot of data, AI techniques, physical plus AI are better. Mm-hmm. Outside of that, in December, that model may not correctly represent what's happening. So with humble AI, we actually look at the zone of competency for your AI system. And outside of that zone, use the normal techniques you use. Inside that zone, use this technique. Businesses love to hear that because now they look at it and they say, this narrowed my business risk. This reduced my business risk. It allows me to try AI in this scope, see how well it works, and then expand. And if I don't have data, I get more data. I see the value of data. That's a business risk. It's a way of adopting digital technologies. We have the same thing in something called explainable AI. Because we use physics plus AI techniques, we can tie some of what the AI does to the actual physics. Because no chief engineer is going to adjust their turbine unless you can tell them, the reason the AI system told you this is because when I look at T42, this vibration sensor, this pressure sensor, and this airflow, it's telling me something's wrong. Then the engineer says, that could be right when I look at the data. It gets them more comfortable. Mm-hmm. So this is business risk. The next thing we do is we use things like lean. Many people don't know where to insert digital transformation. Digital transformation really is business transformation. We just happen to use digital technologies to get that business transformation. Because we use lean actually forces you to look at what's a value stream map. Where is the best way to get value when you start at raw materials or you start at something to a customer? Then what lean does is remove waste, which is exactly what you want. But while you're removing waste, you collect data to understand what to remove. You collect data to benchmark, and you collect data after to say, did you do it? Oh, I have a digital transformation system. I get the data, which is what I always wanted. I can now stick my analytics right there. I know a benchmark, and I can constantly figure out the right data to beat that benchmark. So lean is business transformation, giving us the ability to insert digital transformation in it. So that's the way you get the benefits. You use technologies that allow you to capture the new value and do it in a way that's safe. Now you come to the risk. By doing that, you may expose yourself on the cyber side. Well, there are two envelopes here. One is that there's a significant amount of IT cybersecurity you've got to put into place. And so you will go do that. You will figure out the firewalls, you will figure out everything that you can do to predict threats, and you get that done. Second thing that we're working on, we've gotten a couple of DARPA and the IARPA huge grants over the last 4 or 5 years, $30-40 million worth of grants to look at these techniques. This is really cyber physical. So for instance, because we build the gas turbines, and because the gas turbines run, based upon physics, so there's something called the Brayton cycle. The Brayton cycle says, if I explode gasoline inside these chambers, then based upon that, I generate so much electricity. Then the temperatures are a certain amount. I can know each sensor what the temperature should be. That's physics. Because when you combine gas, you light it, physics. Because we know that physics and we've designed the machine, I can tell you with this control system, exactly what the temperature is going to be at each sensor. So if this sensor here and this sensor here said this one is 200, this one is 400, the one in the middle should be 300. If it tells me 900, I know it's been hacked. So I now have the ability to use physics, because to beat this, you've got to defeat the physics of the universe. So because we know the control system and the design, we now are looking at ways that we could actually figure out when you try to spoof the machines. Other than that, I can also do something. I can vary the controls all of a sudden, because maybe you got in there and found a way to spoof it. But now, because I own the control system, I change all of a sudden the air mixture, I change the fuel mixture. I expect to see those changes ripple across. If I don't see them, all of a sudden I can look now and say, what's going on here? Did someone hack this system? Did someone hack this actual control screen? It could be you have a bad one. I can do other variants to see what's actually happening. So there are ways that you can do cyber physical capabilities to begin to affect these things. We are now working on that. There are large research projects that we're working with DARPA, the Department of Defense, and others on there. And we're taking some of those ideas and eventually bringing them back into those products. But those are the kind of things we're doing as we see the future moving forward. Right? And again, it's using a digital twin, because the digital twin knows exactly how the system should react when you change your controls. If it doesn't react that way, it could be somebody's hacked certain sensors. So it's a different approach, but you have to balance the rewards you're getting with the risk that you have, because that's the only time people take any kind of risk.
Do people have the budgets to actually go in and continue to invest in their digital transformations?
Brilliant question. Perfect. This is why I use lean. See, here's the interesting thing. If you look at lean as it evolved from Toyota all the way to now, what lean does is it removes waste. So what it does, it goes in, it makes you lay out what's the process by which you're doing something, and you follow the process and follow the data stream. What you quickly find out is that as I remove waste, it's because I have all these people doing things that I didn't need them to do. It doesn't add value to the customer. I have all these people waiting, for things that didn't appear, so you're not using the time productively. And by removing that waste, I find I end up with a significant amount of people resources that are free and money. I have less inventory that I'm using. Wow, okay. I know when I need to buy something, so I don't have to prepay for many things. Okay. I have excess resources that I can channel to the right things. So by using lean in our business transformation, what you find happening by that removal of waste, The money that you need for the investment shows up. And I just need a little bit at the start. Then I apply that. When I apply that and I see the benefits, what happens now, the culture changes. Everybody begins to apply it. Then they find waste in every other place. Then again, this gets optimized and then they apply it. And then bit by bit, you find that money accumulates in a very interesting way. And more than that, the smart people accumulate. See, because again, money is one thing. The other thing is the smart people. Because I've taken away the people from doing mundane things, now they get new ideas, and now the growth of ideas with that extra dollars because of low inventory, this thing blossoms. So this is the beauty. This is why I spend all this time really focused on that one part. If I can get the lean transformation in, and this is what with the Larry coming and Pat joining, this is what they bring to it that's so remarkable for me. Because now I can take the digital technology that I've slaved on for the last 3 decades and find ways to insert it in the business process and not worry every minute about, can I prove something? Do I consistently have to get funding at the highest level before? It's generating value. It's actually extracting waste and using that to become better. Great story. I mean, if you see some of the examples we have, it's just phenomenal.
I really want to thank you for joining me, Colin.
No, not at all. My pleasure, my honor.